4a is going to be very, very similar to 1c. We're going to kind of revisit this throughout the year. Really, it's an important thing to understand graphs and all the different parts of them. So 4a is graphing quadratic function. I just have a simple quadratic here. So let's get to it. So we're going to graph and describe the quadratic function. To graph it, we know in this case left 3 and down 2. So for the quadratic, we start at 0, 0, and we're going to go left 3, go down 2. Now, if you watched my last video, this here,
attention in
so we have that 2. This is a multiplier. You multiply instead of, so the quadratic usually starts at 0, 0, the points 1, 1, and negative 1, 1. Instead of these 2 points here at 1, 1 and negative 1, 1, by having this 2 on the outside, it would multiply the y value by 2. So it would bring them up here. Instead of here, they're not going to be there anymore, they're going to be up. So when I move this point over here, at negative 3, negative 2, I moved it left and down. I need to move these points also left and down. So those points go left and down, they end up going here, here. If that doesn't make sense to you, let's do a table. So if we hopefully you know negative 3, negative 2, that's 1 point. On the left side of a number line on negative 3 is going to be negative 4. On the right side of negative 3 on the number line is going to be negative 2. Those are on the opposite sides of negative 3. Let's do each one into the original problem. Original function. So we have negative 4. If I put negative 4 in for x, plus 3, you get negative 1. Square it, you get 1. Times 2 is 2. Minus 2, you get 0. And let's put in negative 2. Negative 2 plus 3 is 1. 1 squared is 1. Times 2 is 2. Subtract 2 is 0. There are your points. So there's multiple ways to get the same problem. And we know it's a quadratic, so it's going to be U-shaped. So we start down, draw like a U. Now, when we're looking at increasing intervals, we're always looking from left to right. It's kind of like, so you're just looking at the left side of the graph, and it's like you're drawing from the left side. All right, that is going down. It's a decreasing slope there. So this is decreasing, and this other side of the U, if you're drawing from left to right, it's increasing. Where's the stop and start is here. It's always the x values. It's x equals negative 3. So we're going to increase an interval. It's going to increase from negative 3 on the x values, and it's going to increase. We're talking x's. As this goes up, it's going to continue to go to the right just a little bit, forever and ever. My graphic is a little off there. But it's going to continue to go to the right forever and ever. When I say right forever, right is the x values go to infinity. Decreasing intervals, this came from, on the x values, came from negative infinity. And where does it stop decreasing? It stops decreasing at negative 3. Domain. Domain is the x values. And so when we come in from negative infinity on the x values, it's going to continue on to positive infinity. It's going to cross over into positive x values, and it's going to go to positive infinity. So you can write this, negative infinity is less than x is less than infinity, or you could write it, x is all real numbers. The range. The range is the y values. Not too often we look at the y values, but for range we do. The range, the lowest y value that this graph is at is at -2. No part of the graph is lower than that. There's no part of the graph that's lower than line I just drew. So I'm looking at -2 is my lowest y value. And there is a point there at -2. Filled in point. It's the bottom of the quadratic. So therefore it's equal to. So there's an actual point there. And then both sides of the quadratic go up forever and ever. And the y values keep on going up and up forever and ever to infinity. The zeros, where's across the x-axis? The zeros are at -2 and -4. The x-intercepts, well, you're thinking, well, that's the same thing as a 0. They are, but we represent them as coordinates. The y-intercept. Where's the y-intercept? Well, my graph doesn't show it. But how can we find the y-intercept? You can always just substitute in 0 for x. If you substitute in 0 for x, you should be able to find the y. So if we substitute in 0, 0 plus 3 is 3. 3 squared is 9 times 2, 18 minus 2 is 16. So 0, 16 is your y-intercept. Domain restrictions. Since the domain was all real numbers, there are no restrictions on it, no asymptotes, no stopping points, and behavior. So here, as x goes to -infinity, the y values go to, so that's the left side of the graph. As x goes to -infinity, keeps going left. What's happened to the graph? It's going up. So the left side of the graph is going up to infinity. Then as x goes to positive infinity, so that's the right side of the graph, the y values go to where? Well, as it's going to continue on in this path to positive x values, and it's going to continue to go up to positive infinity. This will conclude our video. Come to class with any questions. We're going to practice these, and don't forget about your test on Wednesday, the Unit 1 through 3 test. If you have any questions, you need to ask me on Monday. Thank you.